Okay, welcome to Algebra 2, Unit 6.5. How does f of x equals e to the x compare? Well, what's e? If you take 1 plus 1 over x raised to the x, and you just keep increasing that x value until it is like outrageous. Just do it in a calculator right now, like 1 plus 1 over 1,000 raised to the 1,000. What number do you get? And then try try like 1 over 1 million. One more. Raised to the millionth. See what that happens. It's kind of cool because you're going to discover a brand new number probably to you. Kind of like how pi was really cool and awesome when you were younger. Well, e is going to become really, really cool because it is Euler's number. It is super useful. It comes out to being about 2.7182818, and it goes on and on forever. It is a irrational number, but it occurs from this little formula here. And if that looks familiar, remember in the last two lessons how we've taken the 100% plus whatever percent it is? Well, that's how Euler developed this number. He was doing interest. He was looking at interest, and here's what it really is. Well, I'll hold on. Suspense. You can play your suspense movie in the back, or music in the background, like do 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 do. Because oh my goodness, that's what the suspense is. The boards are coming off, attacking me. First, I want you to go into Desmos.com calculator, and I want you to plot these three on one graph, and that way you'll be able to see whether the e is a. Well, I kind of already gave that up. I'm sorry. That way you can see. Well, I'll go ahead and say it. Whether E is or Euler's number is a growth factor or a decay factor. Sorry, that was kind of bad. Okay, so basically we've taken our principal equation and we're adjusting this. Euler's number actually calculates interest compounded continuously. That's how most of our credit cards and our banking is now. So we can shrink this down. I love this formula. I just call it the PERT formula, A equals PERT, because it's your principal times your Euler's number raised to the rate times time. Makes it so easy. So let's work out a problem like that. We have $2,700. We have 2.5% compounded continuously. So to find the effective rate, we are going to plug in Euler's number, raise it to the rate, and subtract 1, just like we've been doing in finding effective rates previously. We end up getting 0.02532. Now, we take this effective rate and plug it in for the R, because that R is effective rate. Then we can take the amount in 5 years that we would be earning on this money. So we take our principal amount, $2,700, Euler's number, 0.025, coming from this effective rate, times 5 years, and we get that it's approximately $3,059.50. Make sure that you're comfortable doing these on the calculator. Ask a lot in class. We'll work as a group on it. Thanks.